Happy Pi Day. Welcome to Speed Up Data Predictions with Real-Time Inference at Scale. My name is Deepthi Mohan and I'm a Principal Product Manager at AWS. In this session, I'm going to talk about how you can analyze and make predictions using machine learning from your data in real time. Before we get started, here's what we'll cover in today's session. First, I'd like to introduce you to data streaming. I will then talk about AWS services that can help you build workloads for real-time data streaming use cases. We will then dive a little deeper into how you can process data streams in real time and how machine learning fits into the picture. And finally, we'll put all of this together and share reference architectures for IoT use cases. So to begin, why are we talking about data streaming? We often hear that the value of data depreciates over time. Whether it's log data from application servers, clickstream data from websites and mobile apps, or telemetry data from IoT devices, they all contain time-sensitive, valuable information. If you think about the millions of IoT devices across various industries, manufacturing, transportation, home automation, and devices in medicine and healthcare, they are all generating data in real time. To maximize the value of data, companies and organizations need to act upon it as it is produced. So what is streaming data? Streaming data is any data that's continuously generated, ingested, analyzed, and acted upon in near real time or real time. And this typically means in the order of milliseconds or seconds. Streaming data flows continuously from sources to destinations and usually hits a common set of stages shown here from left to right on the slide. First, we have data sources. And these are data producers like the IoT devices, the mobile phones, the EC2 instances, the AWS SDKs, or any services that are continuously generating data at a high volume. The next stage is ingestion, and this is an optional layer between the source and the streaming storage that provides value-added services such as pre-processing of data, encryption, authentication, or throttling. For IoT solutions, the AWS IoT Core service would be an optional streaming ingest layer. Streaming storage is central to streaming data use cases. It takes data that's written into it very efficiently and reliably, and this data is stored securely and cost efficiently. One of the key advantages of streaming storage is its ability to decouple the sources from the consumers. This allows these producers or sources to send in data at very high throughput, and the streaming storage stores it efficiently. This data is available for consumption by the streaming consumers, which can be stream processing applications or a wide variety of destinations. On AWS, the most common streaming storage solutions are Amazon MSK, Kinesis Data Streams, and DynamoDB Streams. Which brings us to stream processing. And this is where the exciting action happens. This is the most interesting stage due to all the different types of processing that can be done. And this is where we'll be spending most of our time today. So stream processing can be something as simple as filtering and aggregating streams to sophisticated machine learning that involves acting upon the data stored in the streaming storage layer. In AWS, this layer has the widest variety of services, including AWS Lambda, Kinesis Data Streams, Glue Streaming ETL, and several other open source offerings. One key takeaway for stream processing is that records are read in the order in which they are produced, and that enables a number of use cases. This maintenance of ordered processing is what makes stream processing different from other messaging systems. And finally, once all your processing is done, you want to send this data somewhere, and that is to a destination. These can be dashboards, or they can be triggers to another system like alerts or alarms, or simply you want to store this data in S3, which is by and large the most popular destination, or other databases for further processing. Now that we've covered the basics of streaming data, let's talk a little bit more about the AWS services that can help you achieve your use cases. We have two services, Kinesis Data Streams and Managed Streaming for Apache Kafka or Amazon MSK, that help with streaming ingest and storage. To help with stream processing, we have Kinesis Data Analytics, which is a managed service for Apache Flink. And I'll talk about what Apache Flink is in a minute on the next slide. But before I go into that, the last service I want to introduce is Kinesis Data Firehose, which enables you to capture and load streaming data into destinations such as S3, Redshift, OpenSearch, Splunk, and a wide variety of generic HTTP endpoints. I mentioned earlier that stream processing is the most exciting part of working with streaming data, thanks to the plethora of use cases that you can achieve with it. You can perform simple stateless stream processing with AWS Lambda, where we apply specific logic to each incoming streaming data record. Let's, for example, take an example of a temperature sensor that's capturing temperatures in degree Fahrenheit every minute. To perform some kind of analysis, you need to, let's say, you need the data in degrees Celsius. And this conversion logic can be applied to every data record that's coming in, and it does not depend on any of the previous records. And this is simple to achieve through AWS Lambda because you're applying that logic to every single data record. This is stateless stream processing. If you take the same sensor, but you have a different use case where you need to track the average temperature per hour, this requires you to have windows in the time series that allows you to keep track of the temperature every minute and calculate the average over an hour. While this is a very trivial example, it provides an overview of this type of processing called stateful stream processing, where you need to keep track of all the previous records in order to compute your use cases requirements. Apache Flink is an open source framework and distributed engine for processing data streams that allow you to easily build applications for stateful stream processing. You can read from a variety of data sources like Amazon MSK, Kinesis data streams, or batch sources like S3 to perform aggregations, windowing, and other operations. Apache Flink lets you process your streaming data at gigabytes per second and at sub-second latencies. And the key takeaway for you today is Kinesis Data Analytics is Amazon's fully managed service for Apache Flink, and it's the easiest way to run Apache Flink applications. Some of the high-level use cases in stream processing using Apache Flink include streaming ETL, real-time analytics, and stateful event processing. The simplest and most popular workloads are streaming ETL applications, and these are where you're taking data from a high cardinality source to a lower cardinality destination. Basic IoT analysis is an example of this. You can log your analytics data and you can aggregate these logs from your IoT devices and store those aggregates in S3. So you don't have to store every single record and you just store the aggregates. Real-time analytics includes building dashboards for key business metrics from various sources that allows you to make business decisions in real time. And stateful event processing looks for patterns in streaming data and triggers actions that are outside the system or creates alerts. An example of this would be fraud or anomaly detection, which generally triggers an external process or further investigation of some sort. Now you can incorporate machine learning inference with built-in models with user-defined functions, or you can call an external machine learning model endpoint. We'll be covering IoT use cases with all three of these examples in the following few slides. Let's switch gears and talk a little bit more about the advanced stream processing use cases. Streaming machine learning inference help you make real-time predictions on incoming data using machine learning models. Essentially, you can continuously process and analyze the streaming data as it arrives and use machine learning models to make predictions on the fly. Now, streaming machine learning can be used in a variety of applications, from real-time fraud detection in financial systems or credit card transactions, which allow you to take immediate action to prevent further damage. You can score anomalies or breaks in patterns to indicate any fraudulent behavior. Or you can think of an online shopping use case and recommendation systems in there, where you can look at user behavior over the last 10 minutes or the last 15 minutes and combine it with the past behavior of the user to provide the most pertinent recommendations. There are applications like supply chain analytics or predictive maintenance, which are also common use cases. But because we are focusing on IoT today, let's talk about two use cases in more detail. The first is going to be sensor anomaly detection, and the second is a more complex use case of traffic congestion forecasting. I'll share with you a few reference architectures of how these can be achieved. For anomaly detection from sensors, this is a fairly simple use case where you can think of a single stream of data from a sensor. The goal is to find anomalies in the data. And anomalies can be found using well-known detection algorithms such as random cut forest or clustering-based algorithms, which really, very simply put, are looking for a record that are not like the others in a multidimensional space. These algorithms can be built in with user-defined functions in Kinesis Data Analytics using Apache Flink. You can detect these anomalies and send them to a destination like S3. Perhaps non-anomalous records go to a Grafana dashboard for real-time dashboarding. So here you see a combination of both real-time analytics and a fraud analytics detection. You can use IoT core ingest, IoT core for your ingest, and Firehose to deliver all of your records to the data lake like S3. Going to a more complex use case like road traffic congestion prediction, you can forecast congestion using road sensors, Wi-Fi congestion, where you can imagine your data coming in from a wide variety of IoT devices like car sensors, road sensors, Wi-Fi usage on mobile phones, all put together. And all of these data is sent through to IoT core to Kinesis data streams. And you can feed them to a Kinesis data analytics application with a more complex machine learning model, like a spatial temporal graph neural network. And this is still a user-defined function that resides within your managed Flink Kinesis data analytics application. These can be used to predict anomalies, and they can be marked as red or green depending on where the traffic is most congested. And traffic managers, decision makers, and data engineers can customize this templated solution for their needs, and stream processing can be done in real time as well as with historical data sets that really predict the traffic flow on the road network. Some cities have already implemented such use cases to predict and manage the flow of traffic. Both of these examples were about user-defined functions where you are hosting the machine learning model from within a Flink application and you're running it on Kinesis data analytics. But in the next slide, we'll talk about what you can do if you already have a pre-built machine learning model that's deployed elsewhere. Let's say you already have a model predicting road traffic that sits as a deployed model in either SageMaker with an endpoint or in any other service where you just have a model endpoint. Using the same type of application on Kinesis data analytics, you can now asynchronously call an external AWS service like SageMaker Inference or other Amazon AI services like Lookout to enrich your data with input from a machine learning model. A key takeaway from this and the previous slide is that you can do both batch analytics with streaming data that you want to store in a data lake such as S3. And you are also looking at data that's valuable in real time, as we have seen today. And they can be combined with the historical context that you get from both your batch analytics as well as real-time analytics. Now we have looked at machine learning inference, and you've collected all this data. How do you improve your machine learning model to make your predictions even better? And that's where training comes into play. And this really completes the loop in streaming machine learning. We've taken a look at the inference, and we have talked about data enrichment with an already deployed machine learning model. And that's usually the easy part. But how do you build the model in the first place? Training or building a model takes a lot of effort. And by using the data coming in real time to update the models at a higher frequency, you can get better models than traditional training methods. Feedback loops can be shortened, so it makes it very easy to build these models with the most relevant and recent information. For example, here the training is done using SageMaker training, and you have the output from the Kinesis data analytics Flink application that also goes into S3, and it's fed back to the model for further training. This is the most interesting part of streaming ML, where you can use the data to update models more frequently and improve the model with the most recent information for better predictions. With that, here are the top 3 takeaways from this session. You can ingest, process, and analyze your data in real time with AWS data streaming services to gain immediate value from your data. Kinesis Data Analytics is a fully managed service for Apache Flink that enables stateful stream processing, including running machine learning workloads that can be built both as user-defined functions or with a deployed model that's hosted on SageMaker or other AI services. And finally, if you want to learn more, here's a QR code that will lead you to a blog that shares more about how you can identify anomalies in industrial processes. Thank you for attending this session and hope you have a great Friday.